This week on Weather 101, we're diving a little deeper into the tropics. Last week we talked about the difference between a tropical depression, tropical storm, and what classifies as a hurricane. Talked about how they get their names, how hurricanes' names are retired. But we're going to dive a little deeper into the science this week, Gracie.
We're going to keep talking tropics because, of course, we're getting close to that peak time for hurricane season. So we do want to break down some more details of the tropics. And starting with that, what ingredients are necessary for a tropical cyclone to form? First of all, warm waters need to be present. Water temperature above 80 degrees, and that is something we usually have this time of the year and heading into September, especially in the Atlantic. Those waters get very, very hot. We also need converging winds that force air upward. So we need that rising air.
Right, and whenever you get that rising air and you've got that moist air, that's when you get these storms to develop. You get a tropical cyclone. We've also got a couple of other ingredients needed, though. We need our winds to be blowing roughly in the same direction. You hear us talk about wind shear with tornadoes, how we want that wind shear. Or you want tornadoes to get a tornado.
Right.
Of course, we don't want tornadoes. But anyway, for tropical storms, tropical cyclones, you cannot have shear for it to develop like that.
Right. We need low wind shear for it to hold together. Sometimes when there's high wind shear, we talk about that breaking storms apart.
Right.
But another thing, Austin, this is a fun fact, that hurricanes and tropical cyclones actually cannot form at the equator. So another ingredient necessary for that to form is it has to be 200 miles, at least 200 miles away from the equator.
And that's in order for it to spin. And we'll talk about why we want 200 miles away a little later. Now, we talked about what you need for a tropical cyclone to form, but there's also some things that can inhibit it. You know, thankfully, we don't have hurricanes developing every day. Part of the reason that something that will inhibit tropical development is Saharan dust. So from West Africa, we've got dust from the Saharan desert that the winds carry into the tropics, into the Atlantic Ocean. And the way that inhibits these storms is, you know, we want this water temperature to be above 80 degrees, but whenever that dust moves through, we can go ahead and advance here. We'll show the dust moving in. That's going to cause that sunlight to be reflected. And of course, whenever the sunlight's reflected, either from dust or by the clouds, you know, it's not going to be as warm at the surface. And so that's going to result in your water being lower temperature.
Right.
We're going to have less moisture. And we're not going to have the ingredients as what we need for those tropical cyclones.
Yeah, Austin, usually early on in the season, we see this plume of Saharan dust coming from the west coast of Africa, and that keeps our tropical activity at bay. So we like to see that. That keeps the Atlantic basin fairly quiet, but this time of the year, we don't see necessarily as much of that dust. And like Austin said, it's going to give us some drier air. It's going to keep that activity from forming, and it is going to slow things down in the tropics.
Right. And, you know, we talked about when does the hurricane season peak? Well, here's another map showing you generally when we see the most storms form. This is August. You can see it's getting towards where that water is more heated, and then in September here. That is when we peak in hurricane season, when we have the most activity going on. Past September, though, Gracie, that's when we start to see a decrease in these storms, and the reason for that is because of the water temperature. Now, I know you would think, oh, the summer's the hottest, so that's when the water is going to be the warmest, but that is not the case. And Gracie, you can tell us why that is.
Yeah, that's because water and air, they heat up at different speeds, and it takes a little bit longer for the heat of the water to reach those higher temperatures. So the heat capacity, the amount of heat required to raise the temperature of a substance by 1 degree, notice, is higher for water than it is air. So although it may be the hottest time of the year in the middle of summer, it is not quite the hottest those waters are going to be. And as we just talked about, one of those key ingredients for tropical development is warm sea surface temperatures.
Right, and this graphic will show, as this is just going through a general day. So if we start both the water and the air at 60 degrees, you'll notice the air temperature is rising much faster than that of the water, and it's falling faster whenever we lose that daytime heating. And this is why, as we go towards September, past the peak heating in the summer, that's when we'll have the water will still be the warmest because it's still with obtaining that heat, it's still holding in that heat. But once we head past September, that's when we gradually start to lose that heating. The heat capacity, yes, of water is always going to be higher, but that water will slowly start to decrease in temperature.
Yes. And of course, we also have something else we look at, and this is a climatological feature that we look at every year to really get an idea. The National Hurricane Center will break down what we're expecting going into the Atlantic hurricane season, and that is El Nino versus La Nina as well. So one of these, the El Nino, this is where we're going to be seeing a less active season for the Atlantic basin. That's because it is our cool phase. We have cooler and we have drier air, so that's going to suppress the activity in the Atlantic basin versus the Pacific side where we have warmer and wetter conditions and it's a little bit more active.
That's right, and this all goes back to the trade winds. So during El Nino, whenever we have this warmer water in the Pacific, that's when our trade winds are going to be weaker as they're moving off towards the west. And you can get pretty advanced in the science here, but all you need to know is El Nino is when we have those weaker trade winds, which results in warmer air in the Pacific, colder in the Atlantic, and of course La Nina is going to be swapped. That's when we have those stronger trade winds, which is going to result in the Atlantic being warmer and wetter, which ultimately results in more tropical activity.
Yes, and fun fact this year, Austin, we're in a neutral phase, so neither one of those, but we were just talking about the other day, I think we're going to start leaning more towards a La Nina.
Yes, and unfortunately, as we just said, that's going to result, and we're already seeing the tropics start to fire up a little more, so unfortunately with La Nina, you get more of that tropical activity.
Yes, of course, and if y'all have any more questions, we're going to continue to dive into the tropics over the next few weeks, answering hopefully some of your guys' questions. But if you have any weather-related questions, please email us at WJTV Weather at nexstar.tv, and we will be happy to answer those.